All right, guys, Mr. Jenkins back here. This is going to be your first lesson from Chapter 3. It is called Solving Systems Using Tables and Graphs. Really, for all intents and purposes, it just should be called Solving Systems by Graphing. Sometimes these textbooks can get a little bit fancy. All right. Well, we'll look at some tables and stuff, but in general, we're thinking about solving systems by graphing, which you've done in Algebra 1. As is the case for kind of most of these things. Anyways, just some definitional kind of stuff, and then we'll get to it. It says a solution to a system of linear equations. I should specify this is a I guess for this we don't need to specify. This is for any system, no matter how many variables. Is an, that would be ordered pair. That makes all of the equations true. Or it falls on the line of. All right, so it says to solve a system, we want to, we'll go through all this graph, each line very carefully, look for where the lines intersect. So graphically, the solution, if they have one solution, that would be the point of intersection, and then I would just say test or substitute. Let's go with substitute. That's a better math word. Substitute. So that's how you kind of check your work. You plug them back in, right? So anyways, just to kind of go over this example, the solution to the equation, to the system of equations, negative 3x plus 2y equals 8 and x plus 2y equals negative 8, we can tell is negative 4, negative 2. All right, just by looking at those, looking at what they've shown us on the graph, and just to show you what I mean by this last part, sub your answer back in. Just remember, in an ordered pair, that's an x, that's a y. So if we go back to our originals and sub those in, that would be negative 3 times negative 4, and then plus 2 times negative 2. That's going to give you 8, which we see. So that is good news on the one equation, and then we should get the same kind of result in the other one. So I'll go ahead and do that real quick. So it's 1x, so 1 negative 4. Negative 4. Sorry, lost my foot. Plus 2y's, so plus 2 negative 2's. And then equals negative 8. That's what we wanted. So we see that it works in both, right? And that should always be true, okay? So now we want to solve each system by graphing. Now, it's your decision here whether you want to kind of lean on your graphing calculator or you want to just kind of graph them old school. I would say, you can't really go wrong either way as long as you know what you're looking for. So how about I solve one each way? One, just old school graphing, and then the other we will do kind of look at our graphing calculator for. All right, so the first one I will just graph kind of by hand, right? So my top line here I'll put in blue, and then my other one I'll put in green. Okay, so my blue line, my y-intercept is 0, negative 1. All right, and then my slope is 2. Write that out on this one. B is 0. Let it catch up here. B is 0, negative 1. And M is 2, or 2 over 1. So that'd be up to right 1 or down to left 1. Okay, I could just draw my line, but I'll finish that up later. Okay, and then our green one, B is at 0, 4. And then my slope is -1/2. So that could be down 1 and right 2. And you can see that they're gonna intersect right there. Just a side note, it could also have been up 1, left 2. Okay, so in other words, if I follow the pattern of my blue, up 1, up 2, right 1, if I go up another 2, right 1, there you go. There's that point of intersection. Just kind of finish up the picture here, and then really the one thing that we care about is that. Okay, so just make sure that you write down the coordinates correctly, which would be x equals 2, y equals 3, or 2, 3. Okay, and just to save a little bit of time here, I won't sub those back in, but you should be able to sub them back in real quick. So 2 times 2 minus 1, that's 4 minus 1 is 3, so it works there. And then -1/2 times 2 is, let's see, -1 plus 4 is 3, so it works in both. All right. Then we have example 2. So for this one, I'm going to lean on my graphing calculator a little bit more. So let's look at that. So instead of just thinking about M and B, I'm just going to go ahead and type these in. I'm going to clear out. So I went to y equals to graph anything. So first thing I want is -1/4 x plus 3. So I've gotten this question several times. How do I do a fraction in this calculator? Where's the fraction button? The answer is there's not one. So a couple ways you could do that. So let's say we wanted -1/4 times x. So one way is do parentheses and then -1 divided by 4. So that's a way to do a fraction, and then times x plus 3. So x plus 3. So there's 1. And then the other one is going to be -3/4 x plus 1. So another way to handle the fraction would be to turn it into a decimal. I know 3/4 is 0.75, so I'm going to go -0.75 times x, and then plus 1. And then I'm going to keep in mind my colors here on my screen. My top line is going to be in blue, and then my other line is going to be in red. Sorry about that. Means my meeting is about to almost about to start, so I'll have to hustle. All right, so now we will go to the graph. And look for a point of intersection. So thankfully, this one's on our screen. Now it looks like they intersect at -4, maybe +3. But you definitely want to go to your table to be sure, right? It's not obvious because we don't have grid lines going all the way across. Plus my window is weird. So let me make that actually. No, it's not. It's okay. So I'm going to go to my table just to kind of see. All right, so we thought they intersected where x equals -4. And right here we can see that they do, right? When x is -4, the output for the blue line is +4. The output for the red line is +4. So now I can tell by looking at my graph that that's my point of intersection. Now, I guess the other part of this would be how can you, like if this is a MathXL problem, how can you use this to you know, because you're probably going to have to graph on a few. So I would say one point you could use for both of them would be the point, that point of intersection. So -4, +4. See, 1, 2, 3, 4. Don't want to graph that wrong. And then from there, you could just use the slope, or you could also just look for another point, right? Another corner point, as I call it. So on the blue line, another point would be 0, 3. So an obvious point, you know, is the y-intercept, and the red one would be go through 0, 1. So then that would be enough for MathXL, but just to finish the picture, you have this guy, and then you also have, those shallow slopes are always a little bit tough to graph. Okay, so that's how you could use Desmos or a graphing calculator. And you could even produce a good graph on paper. Okay, so like I said, I don't really care whether you kind of use your technology there or if you want to just graph them by hand. Let's see if there's anything else. All right, so in some cases, you may have to solve for y. If you're going to use your graphing calculator, you have to solve for y. Like you wouldn't. I guess you could graph them in standard form. Well, if you think about your intercept here, x would equal 12 over 8, so that wouldn't be a real good one. So yeah, you'd want to go ahead and solve for y. And just to kind of review that process, what they did here was they moved over the 8x. So that would give you 4y equals negative 8x plus 12. And then divide everything by 4. And then that's what we get. Y equals negative 2x, because negative 8 over 4 is negative 2, plus 3, because 12 over 4 is 3. Okay? And then, so at this point, we kind of notice, you know, and then we solve for that y, we get a same slope line. All right? If you ever get a same slope line, that's going to be a red flag. It's either going to be IMS or no solution. Or all real numbers and no solution, whatever you want to say there. So essentially these are parallel lines. We already know that. So 1, we start at 0, 3, and then we can go you know, up to left 1 or down to right 1. And the other one we start from here and we follow the exact same pattern. So you can tell that they are just never going to cross. So this would be no solution because clearly, graphically, we can tell they wouldn't cross. So graphing can be a pain, but it gives you a good visual representation of why they have no solution. Okay, and then this one, again, they've already solved for y for us. We see same slope, same y-intercept, which is not obvious until you solve for y. So that would be 2 equations that are actually the same equation. They're equivalent equations, and therefore, this one has, go up 7, right 1. So this one would be, I like IMS. I say IMS. You could say all real numbers. You could say, I think they say identity. Okay, there's a lot of different ways to say that. All right, so well, here's a couple more ways to say it. So consistent, consistent is another way to say. I don't remember which is which. Let's see. So infinitely many solutions is consistent. So that's another way to say it. So has at least one solution. Oh, sorry. I'm misreading this. Sorry about that. So let's see. Consistent would be, all right, so consistent could be either one solution or IMS. So if it's consistent, I won't really use these words, but just to kind of fill in the rest, it has at least one solution. Inconsistent, the only one that's inconsistent is a no solution. Independent would be, that's the only place we see this word, so that would just be one solution. And then dependent just shows up here, so that would be infinitely many solutions. All right, so anyways, that will conclude the lesson. Hopefully this video helps. I would encourage you guys to try to be really active listeners. Try to ask more questions when you're having trouble. Do whatever it takes to make sure that you're understanding the material as we go, because, you know, as we've seen, that is important. You know, and pay attention when you're doing the math excels. Like, you know, even if you get the material, like, are you making little mistakes on how they want you to enter the answer, etc. We want to get better at those little bitty details. paying attention to detail, all that good stuff. So anyways, thank you guys for your time. Hopefully this helps, and you guys have a wonderful day.